All right, so let's take a look at cable test here. So our objectives. Where's our cable test port? What are our WireView mappers? What's open TDR versus terminated? And let's take a we're going to take a look at some of the different cable test results. So first off, our management port up there is our cable test port. So if I switch over here, and this is where right now I'm connected to this, we'll unhook our fiber. And I'm going to be good. I'm going to put my dust caps on there. That way, with the dust caps, we know that any dust that was on the end of the fiber is going to stay on the end of the fiber, so we don't lose that dust. I'm being a little bit facetious there because every time I get new patch cords, I always test them to take a look at the end to see how they look. And I had one of my customers say, why do you even bother doing that? I said, because they come dusty from the factory. Just because they're new doesn't mean that they're not dirty. All right, so we'll put that cap on there. Okay, so I'm going to unplug that, but we don't lose connectivity to our EtherScope. Why? Because I'm connected via the wired or wireless port. Okay, so now this port right here is our cable test port. So I'm going to grab a cable and we're going to plug in one end of that cable right there. And we're going to go to cable test. And it's going to automatically start running a cable test. That's going to show us that that cable right there is 106 feet long. Well, that's cool. Now, sometimes when we run a test, we need to terminate the end of that cable. So that is where our WireView adapters come in. So with our WireView adapters, here's my little bag. So I believe, and I hate to jump out there too much, but I believe that with the standard EtherScope, you get WireView adapter number 1. With the kit, you get 2 through 6. Now, I could be wrong on that, and I hate to even say it because I don't like to be wrong about those things. But our WireView adapter allows us to terminate the other end of the cable. Now watch what happens when I plug that into the far end of the cable and I rerun my test. We see that it shows number 1 out there at the far end. It shows our cable is 106 feet long, and we don't have continuity on our shield. Now what I'm going to do is let's crack this. These are brand new, not even opened. We're going to grab out this one. It's number 6. So if I plug number 6 in and I rerun my test, we'll take a look at the results we get. It should tell us number 6 is up there. So these WireView adapters are great if you go into a facility where somebody didn't bother documenting the cable plan. I could go in and plug in 1 through 6, write down where I plugged them in, and then when I go into the wiring closet and test it, I can say, oh, number 1 goes out here, number 2 goes out here. It's a nice way, or I can test multiple cables without having to run back and forth and move the WireView adapter each time. Open TDR versus terminated. Open TDR is a case where there's nothing at the far end. Terminated is where I have a WireView adapter at the far end. So if I do an open TDR test, I can measure length, I can measure to see if there's shorts or a split pair. With a terminated test, I can get the cable ID, broken pairs, and rolled pairs. So here's the thing. If I don't have a terminator at the far end, I can't tell if somebody has miswired it as far as wiring, say, pin 3 to pin 2. Why? Because it's just measuring the length out there. It's not measuring pin to pin continuity. So here's a case where I do an open TDR test. Now, that open TDR test will not tell me if I have a broken pin at the far end. As an example, we're going to take this cable right here. Let's move some things over just a little bit. And I've got this box that I built. And in this case, this one right here, pin set ports 7 and 8 are not connected at the far end. So let's run our test. So in this case, everything looks good because the bad connection, the broken pins are out at the very far end of the cable. So watch this. If I come in and I find cable number 5 here, and I rerun this test, I've now terminated this with one of my WireView adapters. Notice that 7 and 8 is broken. So in that case, I needed to have that terminator out there to see that I had a connection problem at the far end. So an open TDR test will tell me how long the cable is. And if I have a break anywhere from the EtherScope, it's got to be pretty close to the ether. It's got to be a ways from the far end for me to be able to detect that break. Okay. So there's our terminated test. We can see what that looks like. So here's a short. So in this case, we can see that 4-5 is shorted somewhere along that path. So it gives us an idea that that we've got a problem with the 4-5 pins in there. Here's a split pair cable. So did I grab? Well, I didn't grab my split pair adapter. Not something you'd normally have around your office. But what is a split pair? Split pair is where somebody did not bother to follow the 568A or 568B wiring code. And so in this case, they may have run pin 1 to pin 1, and the way that it's been wired up, 3 goes to 3, but 3 may not be part of the green pair. What this does is this causes an excessive amount of near-end crosstalk, and that's how the EtherScope is able to determine that it's a split pair cable. Continuity-wise, this is wired 1 to 1, 2 to 2, 3 to 3, but they did not follow the 568A or 568B wiring code. As a result, if it even connects, this cable will cause all kinds of issues. So with a split pair cable, tells us somebody wired this cable completely wrong, although we still have continuity. So if you had a low-end tester that only had LEDs on it that looked to see if there was continuity, it would show that it does. EtherScope will detect that that cable is not going to be any good. Broken pair. So in this case, we can see that our cable run was 246 feet or 264 feet, but we're open at 103. So this tells us that at 103 feet from the EtherScope nXG, we have a break. So now I know how far out to go to take a look. Rolled pair. Now this is an interesting one. With the rolled pair, if we don't have a terminator at the far end, it looks like a good cable. But once we put the terminator on there, we can see that somebody has gotten the polarity reversed on all these pairs. So the lesson here is to get the most accurate results, using a terminator at the far end is going to give us a good view, or to get the most accurate results, use a terminator at the far end, one of those WireView adapters. Okay. Now, if I click on my 3 dots in the upper corner, I can upload this result to Link Live. So I can put in a wall jack number, problem ticket number, what have you in here, and I can upload that to Link Live to say, hey, they couldn't connect at gig. I went out, did the cable test. We found out 7 and 8 was broken, 4 and 5 was broken, 7, anything other than 1, 2, 3, 6, we can see what the issue was out there. So there we go. It shows that there's our attachment. It's got our screen image. Shows us what our information is with those results. So on the cable test, it's a great way to be able to come in and see, you know, how much wire do I have here? I could take and plug that. I could slap a RJ45 on the end of a spool of wire, do a quick open TDR test, and see how much wire is left on that spool. How long is this connection? Do I have an issue like a crossover cable? This came back here. We'll move this to this one. We'll find number 4. It's always the last one. I'll hit start on there. There we can see that that's some old crossover cable. Cut that thing in half and throw it in the garbage can. We don't want that out there on our network. Okay. Now, what happens if I plug into an active device? So I'll come in here. I'll plug in that. There it shows me I'm connected to an active device. So it can see that that could be a switch. That could be a PC. Don't know what it is right off, but we do see that it is an active device out there. Whoops.